do some more problems. And I recommend that we look at this first and say, is this in exponential form? And the answer is yes. This one's ready to go. Turn it into a logarithm. So if you read this the way it should be written, it's 6 to what power would give me 11? And that power is a little complicated. So when there is a question of 6 to what power gives me 11, then it's really going to turn into log base 6 of 11. You just have to know where the numbers go. Equals 2n minus 3. Now, I don't know what this is, and you don't know what this is. We don't know. Just to be clear, 6 to the 1 is 6. 6 to the 2 is 36. And so I need it to be an 11. Well, 11 is somewhere in between 6 and 36. So my exponent is somewhere between 1 and 2. It's a decimal. So we're going to have to figure it out. Use technology. Unless you can somehow do this in your head, there are very few people on the planet that can. I am not one of them. 1.338 equals 2n minus 3. Now I have a recommendation here, and I'm not showing my work on the calculator as I do it, and yours might be on Desmos. But what I recommend you do is you're going to write 1.338, but as you do the problem, you're going to carry the entire decimal with you for accuracy. This is really going to come in handy a lot more later. So we're going to have 2n equals 4.338. And so when I add 3 to that, I have 4.338, 290833. So I have more accuracy here on my calculator or in Desmos than I do on my paper. That way, if I have to divide by something, which I'm about to do, or do some other things, I am carrying some level of accuracy with me, and I don't truly round it off until the end. Just a good practice to have. If you round too soon, you lose some accuracy. It's tragic. So n equals, well, that divided by 2. So we'll divide that by 2, and we have 2.169. Okay, that's fantastic, and it is correct, but I do want to show you that if you check your answer, you won't get what we had to start with. So let me switch colors here for a second. We're going to switch to blue, and we're going to go 6 to some power. Well, 6 to the 2n minus 3. Okay, so 2 times 2.169, because that's what n was, and then minus 3. It better give me 11, but again, I'm telling you it's not going to because we had to round. So when you type this, you're not going to get exactly 11. You're going to get like 10.9999 or something like that. I also want to show you this. If you're going to type this in the calculator exactly the way it looks, let me show you what Desmos will do to you as of right now when I record this video. That's not what I wanted to write. This is what I want to write. 6 to the 2, 2.169 parentheses. And then when you go to type that minus 3, it's going to kick you down and put you down there. And we don't want that minus 3 down there. We want it in the exponent. So the best way to overcome that is to put the entire exponent in parentheses. It looks a little bit clunky, but it works. So these are the same thing, but if you're going to use Desmos and put that minus 3 up there, you'll need a parentheses around the entire exponent. So let's do it. 6 to the, just checking my answer. It's for fun. 2.169 and then minus 3, and I got, oh, there we go. 10.994, which is not 11, but it's super close because we had to round, right? So that one is correct. We're going to move on to the next one. Let's do a handful of other problems, and let's start going a little bit faster. And these are going to require a little bit more work before we ever actually begin. When I say before we begin, before we convert it into logarithmic form, which has been the way we started the rest of these problems so far. Like up to this point, the very next line, don't write this. The very next line would say log base 5 of, okay, well great. Log base 5 of what? 99? Or what about this 3? See, we have some things to move first. So before we get all carried away doing that, let's do this. I need to subtract 3 from both sides. You don't have to show all those works, all those steps, all that work. Bad grammar. My grammar be bad. 96, there we go. And now we are ready to write this in logarithmic form because this is truly exponential form. If I were to start writing log base 5, like I can identify all the parts. If I started up here, like what am I going to do with that 3, right? So there's too much that you wouldn't know where to put it. 96 equals n minus 2, there's that. And now I need to find out what 5 to what power would give me 96. And if you want to get all crazy with it, I'll go ahead and tell you it's somewhere between 2 and 3. And here's the brief explanation that you don't have to write. 5 to the first is 5. 5 to the 2 is 25. This is just a good way to kind of guesstimate. Very rough estimate. 125. Well, okay, well, 125. Okay, well, 125 is too much. 25 is too small. I want a 96. So if I have a 96 up in here, and you've seen this before, I have a 96 here, then my exponent is going to be somewhere between 2 and 3. My final answer is not, because we have to do some stuff to it. We have to add 2. So let's go to Desmos or a calculator, or way back in the day. I say way back, just a few decades ago. There would be entire tables of values that you would have to use for this type of thing. It was fun. All right, there's that. And there were some of them that we just knew, like that might be a 125 and you would just have to know that it's a 3. Anyway, reminiscing. Good times. We're going to add 2 to both sides. We add 2, and so n equals, and we can do this one in our head, 4.836. Okay, there's that one. Let's do a couple more in this video, and then they're going to start getting a little bit different. Actually, not harder, just different. Okay, 3 times 8 to the 2n, and then we're going to add 1, and we're going to get 17. Actually, this one is doable in your head? No, it's not. Okay, sorry, forget what I just said. I would love for the very next step to say log blah, blah, blah. No, it's not. And again, here's why not. And don't write this unless you really want to. Log base what? Well, I'll go ahead and tell you it's an 8, but what are you going to do with that 3? What are you going to do with that 1? They're in the way. This is not truly exponential form. So let's make this exponential form. Now, I also want to warn you that a lot of people would look at this and say, oh, 3 times 8, that's 24. Oh, no. 3 times 8 is not 24 in this context. We need to divide by 3 first. So we have 8 to the 2n, and that is equal to 16 thirds. You can go ahead and type that in your calculator. Please don't. 5.3 repeating. You can do that in your head, actually. And so now we are ready to write this as an exponent. Log base 8 of 16 thirds equals 2n. Okay, we are going to figure out what this is. This is going to be a little tricky. I want to ramble for a second. Same thing we've been. 8 to the 1 is 8. You don't have to do this every time. This is just me rambling, estimating answers. And 8 to the 2 is 64. Almost said 16. Woo, that would have been tragic. And here's the deal. 16 thirds is 5.3333333, so 5.3 repeating. Well, that's less than 8. 8 to the 0 is 1. Someone's knocking at my door. And come on in. And so 5.3 repeating is there. So my answer is going to be somewhere between 0 and 1. All right? So we're going to type this in. We're going to figure out what it is. 8 log base 8 of 16 thirds. Let's type it correctly. That would be a good idea. And we're going to have 0.805 equals 2n. We're going to divide both sides by 2. Let's divide our answer by 2. And we're going to have 0.403. Now, technically it would be 4025, but we are sticking with 3 decimal places because that's the way I like to do that. Okay. Whoops, dropped my calculator. Let's do one more in this video, and then we will transition to a different type of problem. 6 times 4. Don't say that's 24, because it's not in this context, because the 4 has the exponent, and the 6 does not. Okay, this is not a logarithm yet. Don't turn it into a logarithm. Let's add 2 to both sides. 6 times 4 to the 2 minus x equals 21. Okay, now what? Okay, again, 6 times 4, don't call it 24. Now, right now, we're going to divide by 6 instead. And we're going to have 4 to the 2 minus x, and that's equal to 21 over 6. Go ahead and type that in your calculator if you really want to. I recommend you don't, because you can probably do this one in your head. Actually, let's reduce this. 3 goes into that, 3 goes into that. 7 over 2, that's 3.5. Let's not overuse the calculator, okay? So 3.5. Okay. So log base 4, 3.5 equals 2 minus x. All right, I want to find out what this is. Now, we could go through the whole process again, but I'll go ahead and tell you that this is between 0 and 1. All right. So because this number is less than 4, so it's going to be between 0 and 1. The exponent, which would be this, would be between 0 and 1. So we're going to type it in the calculator. Log base 4 of 3.5. Haha, I told you it was between 0 and 1. 0.904. That's equal to 2 minus x. And we're going to solve. Now, I think it's going to be pretty straightforward at this point. We're going to subtract 2 from both sides. And when we do that, we're going to have negative 1 point. Trying to do that in my head. Having a little bit of a brain fart. Yeah, there we go. 0.96. And then at this point, we have negative x equals negative 1.096. So positive x equals positive 0.096. That's it.